Well, good evening, class. This is lesson 4.3, and there's an awful lot of stuff in here. Now, it's stuff you should have seen before, so this should be mostly review, but we're cramming a whole lot into one lesson. Okay, so we're going to talk about prime numbers, composite numbers, prime factorization, and GCF, all in this lesson. And actually, this is one of those lessons that's a little out of sync between Course 1 and Pre-Algebra. So actually, I have, we've just recently done this in Course 1, so I have 3 of my Course 1 students who just are getting ready for a test on this, and they're coming in, and so let's say hi. So first we have Hiba, and then we have Lucy, and finally we have Izzy or Isabel, and they're going to help me with the video today. And so we're going to talk about prime and composite numbers to start with. Okay, and so a prime number. Do you guys remember what this is?
Yeah.
It's a number that has what?
5, 7, and 11, not 1.
Okay, there's that little rhyme that a lot of people remember. Okay, the definition is it's a positive integer. Okay, we're not going to worry about negative numbers or 0 or 1 for now. Actually, we can talk about 1 in a minute. But it's a positive integer with exactly 2 distinct factors. Now, I underline the words exactly and distinct. Okay, the reason I underline distinct is because a prime number has to have 2 different factors, right? Not right, and there have to be exactly 2 of them. So 1, you just heard somebody say the little rhyme. They said 1 is not prime. Why is 1 not prime?
Because everything goes into it.
No.
No, it goes into everything.
Yeah, but why is 1 not prime? It's divisible by 1 and itself. Isn't that what most people usually say a prime number is?
Yeah.
Well, why does that make 1 not prime? It's divisible by 1 in itself. The problem is that 1 and itself are the same number. So does it have exactly 2 distinct factors? No. It has 2 equal factors. Okay? And by the way, I need to point out that we have been joined by Reese. Reese, are you going to be part of the video?
Yep.
Okay, cool. Come on. All right. So a prime number is a positive integer with exactly 2 distinct factors. Now, a composite number are the numbers that have more than 2 distinct factors. So something like 6 is divisible by 1 and 6, 4. And also 2 and 3. 4 is an example of a composite number. Okay,
9.
stop yelling things out. 4 is a composite number because it's divisible by 1 and 4 and also 2. Okay, 8 is composite because it's divisible by 1, 8, 2, and 4. All right, so we have basically every number from 2 up is either prime or composite. Okay, the only exception is 1, and 1 is neither. So I'm going to go ahead and write that in. 1 is neither prime or composite. Okay, and so what some books do is they only say for prime and composite numbers just start at 2 and only look at numbers bigger than or equal to 2. There's also 2 special prime numbers, 2 and 5. 2 and 5 are special because 2 is the only even prime number, and 5 is the only number that ends in a 5 that's going to be prime. Because, and the reason is, every other even number is going to be divisible by 2. So it's going to have more factors than 1 in itself. And every number that ends in a 5, we know from the divisibility rule lesson, okay? From the divisibility rule lesson, we know that anything that ends in a 5 is divisible by 5. So anything other than the single digits 2 and 5, all other prime numbers, and here I'll throw one more thing in. After you get to 11, all prime numbers have to end in 1, 3, 7, or 9. Well, if you think about that, that makes sense, right? They can't be even, so that takes care of 0, 2, 4, 6, 8, okay, as being last digits. And they can't end in 5 because they'd be divisible by 5. Now, it doesn't mean that everything that ends with a 1, 3, 7, or 9 is prime. No. It just has a chance at being prime. If it doesn't end in those numbers, it can't be prime.
That's why you can have like a 50-50 chance.
Not even 50. It's like a 40% chance. All right, so let's keep going. All right, so let's continue. So the other thing that we're going to be talking about in tonight's lesson is greatest common factor, which we usually abbreviate with GCF. Now I want to break this down by exactly what we're talking about when we talk about greatest common factor. So let's start first with the word factor. What is a factor? It's a number that does what?
Goes into another number.
Right, exactly, Isabel. It's a number that goes into another number. Okay, so it's a divisor. Think about the divisibility rules. So the factors of 10 are the numbers that divide 10. 1 and 10, 2 and 5. Okay.
Yeah.
Now, if I take 2 numbers, like let's say I put down 12 and 20. Okay? If I'm looking for factors of 12 and 20, I'm looking for numbers that go into 12 and 20. Now, the let's go to the second word now. Let's go to common. What does it mean to be a common factor? Well, it means it's a factor of both numbers.
Yeah.
So it's a factor they have in common.
Yeah.
Makes sense, right? There's no weird math jargon here. It's not like somebody came up with this crazy name, greatest
It's
common
not
factor.
rocket science, guys.
Exactly. It's pre-algebra. All right. So a factor is a number that divides another number. Common means we're looking for factors to divide both 12 and 20. And we want to find the greatest. Well, that just means the biggest. We want to find the biggest number that does that. So what's the biggest number that goes into 12 and 20? Well, there's a couple ways to do this. The brute force method, which I don't recommend, is to take the two numbers 12 and 20 and write down all of their factors. So 12 is 1 and 12, 2 and 6, 3 and 4, and then you double check and you make sure you've got them all. Okay?
Do that with big numbers.
Yeah, and see, it's okay for these small numbers, but like Lucy just said, if you do this for really big numbers like 280 and 360, oh my gosh, would it ever? Okay, so let's see, the factors of 20 are 1 and 20, 2 and 10. I'm kind of doing factor rainbows without drawing the rainbow. Okay, you could actually draw the rainbows if you wanted to.
I don't like the rainbow part.
Okay, well, thanks, Hiba. And so 4 and 5. Okay, and so those, I think, are all the factors of 20. There's a danger here, too, because you're having to do a lot of work. You can make a mistake. So now we look for the biggest number that's in both lists, and it looks to me, let's see, 20, 12, and 10 are big, but they're not in both lists. Yes, Isabel is whispering 4, and I think she's right. 4 is the biggest number that's in both lists. So the GCF
It's 4.
of 12 and 20 is equal to 4.
But there's an easier way to do this.
There is a much easier way to do it, and that is involving division ladders. Now,
Oh,
division ladders,
favorite
yes,
method.
this is definitely my favorite method. So I'm going to write down the same two numbers, 12 and 20.
It's
and
also
I'm going to look.
Isabel's.
I think it's all of our favorite numbers. So
And mine.
what's an easy number goes into 12 and 20?
2.
Right, good job, Hiba. 5 goes into 12 and 20. Okay, that's why we brought her along. She is our comic relief for tonight. So no, 2 obviously goes into both of them, right?
Yeah.
That's what you meant to say. All right, so 12 divided by 2 is 6,
6.
and 20 divided
10.
by 2 is 10, and that is correct. All right. Now, does anything go into both 6 and 10? Reese, you've been awful quiet over there. What goes into 6 and 10? They're both even, aren't they?
2.
Take another 2 out, right.
Oh.
So take another 2 out, and now we get it all the way down to 3 and 5. Now, does anything go into 3 and 5? I'm sorry,
Nope.
that looked like a 6, but yes. No, nothing goes into 3 and 5.
Because they're both primes.
So now what you do is you take all the numbers that you divided out, which are the two 2's, we multiply them together, and this 4 is the GCF. And now, without having to write out all those factors or risk missing something, I have the GCF. All right, this is called the division ladder method. It also works on if you have more than 2 numbers. Like if you have 3 numbers, just write them all down. So if you had 12, 20, and 24, fine. Write them all out and do the GCF the same way. In fact, it turns out if you had 12, 20, and 24, it would have also been 4. Now there is a third way. And the third way a lot of people like, but hold on a second. Lucy's got a question. Go ahead.
Could you do it with more than 3 numbers?
Yep,
Like,
4, 5, technically, yeah, you could. The more likely, what happens when you get more numbers, the more numbers you have, the less likely you're going to find a decent sized number that divides all of them.
Yeah.
So the more numbers you have, the more likely the only number that's going to divide all of them will be 1. And by the way, that is the GCF of worst case scenario. So everything's divisible by 1. Okay, that's what you guys were rattling on about before. And so if I say, what is the GCF? The answer will never be there isn't one. Worst case scenario, at least 1 goes into everything. So 1 is the GCF. But usually if you can find something greater than 1, well, obviously if you're looking for the greatest common factor, unless 1 is the only factor that's in common, there will be a bigger one. All right, the last way you can do GCF is you could take the numbers 12 and 20. Let's change colors, actually. Let's change to blue.
purple. Aw.
I don't have purple up right now, but let's change the color to blue. And we'll take the two numbers 12 and 20, and we do the factor trees. This is the last way. And we break down the numbers until we have all prime factors. Okay? So 20 would break down into, what, 4 and 5?
Oh, yeah.
And 4 breaks down into 2 and 2. So now the factorization
Don't
of
forget to
12...
circle 5.
Thank you. The factorization of 12 is 2 to the second power times 3. So that's using the exponents from last night's lesson. And then over here we get 2 to the second power times 5. And now we look for what do they have in common. Well, they both have 2 2's, 2 to the second power. And so that is the GCF. So they both had a 2 to the second power. So the GCF
It's 4.
again, is 4. And so all three of these methods give us the same answer.
Yep.
All right, now, there are times where you want to use one method and not the other. Division ladder, as we all agreed unanimously, is probably our favorite method. It's probably the easiest.
Yeah, pretty much.
The next would probably be the factor trees, and then the worst one, especially for big numbers, is to try to list out all the factors. However, if you have fairly small numbers, like if both your numbers are under 20, like 5 and 10 or 12 and 18 or something like that, if your numbers are pretty small, there aren't that many factors, so the first way is not that terrible. Okay. Also, sometimes you'll have a question where they'll actually say, suppose the two numbers are 2 to the second, 3 to the third, times, that wouldn't be prime, times 5, and the other number was 2 to the third power times 3 times 5 to the second power, where they've already got the prime factorizations. Well, now you'd be kind of silly to multiply this all out and then do the division ladder. So if they've already given you the prime factorizations, then obviously you would use this method. So what would the GCF be here? Well, how many 2's do we have in common?
2.
Only 2, right, because one has 3, but the other one only has 2. How many 3's do we have in common?
1.
Only 1.
No,
The top one has 3, but the bottom one only has 1 3, so it's only 1 3. And how many 5's do they have in
1.
common? 5. So if you multiply 2 squared times 3 times 5, I'll do the hard part first. No, not to, well, hold on, but it's easier if you do 3 times 5 is 15.
30.
2 times 2 is 4, and 4 times 15 is 60.
All
right, and I believe we've got another class that's about ready to come in. Yep, it is 10:10. So I'll have to resume finishing this video a little bit more, but right now I want to say thanks to Reese and to Isabel and to Lucy and to Hiba, and we'll wrap up this video in just a second, folks. But thanks for stopping in, guys, and everybody else. We're going to do a couple more things. Actually, I think that's probably enough to get us started on the lesson for today. So I'm going to wrap it up here because we're already at 12 minutes. So thank you everybody for watching, and have a good night, and have a great and safe Halloween tomorrow night. And we will go over GCF questions in class on Friday. Okay? Take care, everybody. Bye.